တော်လိုင်းအောင်မြင်မှုအဓိကထားရမယ်နော်အရေးတခြားပြည်သူလူထုတွေကဝိုင်းပြီးပါဝင်လို့ရတဲ့ပညာရေးအဖွဲ့အစည်းတွေမှာဆိုရင်ပညာရေးလုပ်ငန်းတွေမှာနော်ဒီစေရဘုံနာပါဝင်တဲ့အဖွဲ့အစည်းတွေကဝင်ပြီးလုပ်ပါမယ်အဲ့လိုလုပ်တာကိုလည်း NUG တွေကအတိအမှတ်ပြုပါမယ်နော်အတိအမှတ်မပြုရင်နေလေခုနပြောလို့စန့်ကျင်တဲ့ဟာတော့မလုပ်ဖို့အရေးကြီးတယ်နော်အဲ့ဒါကိုတော့ကျွန်တော်ပြောနေတာပေါ့ဒီမှာရှိတဲ့ဒီအဖွဲ့အစည်းတွေကဥပမာကျွန်တော်တို့ဆိုရင်ဒါဒီလို IBN ကိုလုပ်တာကိုဒီ NUG ကနေပြီးတော့ memo ပြစာထုတ်လိုက်တယ်ထုတ်တဲ့လူကဘယ်ကောင်ထုတ်လာတော့မသိဘူးနော်အဲ့လိုထုတ်လိုက်တဲ့စာကြောင့်ဒီကိုယ့်ရဲ့တော်လိုင်းအဖွဲ့အစည်းကြီးချင်းကိုယ်ခွဲအောင်လုပ်တဲ့ပုံစံမျိုးတွေကအဲ့လိုတွေဖြစ်တာလားနော်အဲ့လိုဖြစ်အောင်အကြောင်းဖန်တီးတဲ့လူတွေကိုနော်တေချာစီစစ်ဖို့လိုတယ်ဒီလိုလူတွေကတော်လိုင်းကိုဖြတ်စည်းနေတဲ့လူတွေပဲနော်အဲ့ဒါတွေကကျွန်တော်ပြောရင်လည်းချက်တော့နောက်တစ်ချက်ကတော့ကျွန်တော်ပြောရင်တော့ဒီလိုနိုင်ငံခြားငွေတွေကနေပြီးတော့လဲပယ်မှုတွေရှိလာလို့ခက်ခဲလာတဲ့အတွက်ဒီကျောင်းသားတွေအနေနဲ့ဆိုရင်နိုင်ငံခြားသင်တန်းသင်ယူညွှန်တန်းတွေကိုတင်ဖို့ကခက်ခဲလာတယ်ဒါပေမဲ့ကျွန်တော်တို့ IB ရဲ့ education group ကတော့အစကတည်းကကျွန်တော်တို့ကတော့အကျိုးမြောက်လို့ညီမတာပေါ့ဘူးကျွန်တော်တို့ operation လုပ်နေတဲ့ပတ်စံနဲ့အထူးကနေပတ်စံလည်းမဟုတ်ဘူးတခြားဗမာပြည်မှာရှိတဲ့ကျောင်းသားတွေစီကကျွန်တော်ရယူတဲ့ပတ်စံလို့ကျွန်တော်တို့လုပ်တဲ့လာကနေကျွန်တော်တို့ကနေပြီးတော့နော်ကျွန်တော်တို့လုပ်တဲ့လာကနေကျွန်တော်တို့က website တွေထားပြီးတော့လုပ်နေတာအဲ့တော့အစကတည်းကကျွန်တော်ကစေတဝန်ထမ်းကိုအဓိကထားနေတာဒီလူတွေဦးတော်လာရေးကာလမှာလည်းပဲပညာရေးစစ်မျက်နှာကနေပြီးကျွန်တော်ဝိုင်းပြီးတော့တိုက်နေတာဒါမအောင်မချင်းကျွန်တော်ဝိုင်းပြီးတော့တိုက်ဖို့နော်အစင်နဲ့ပဲနော်အဲ့ဒါကိုကျွန်တော်ကတင်ပြနေတာဖြစ်တယ်အဲကြောင့်လို့အချုပ်တော့ပြောရရင်တော့ဗါလဲဆိုရင်ဒီ NUG ကိုအဓိကထားပြီးမဝေပါပါနဲ့ NUG အနေနဲ့ကတော်လိုင်းအောင်မြင်ဖို့ပဲအဓိကထားပါနော်ဒီခုနပြောတဲ့ပညာရေးတွေခုနပြောတဲ့နော်ဒီလိုလူမှုရေးကိစ္စတွေနော်ဝိုင်းပြီးလုပ်နိုင်တဲ့အဖွဲ့အစည်းကဝိုင်းပြီးလုပ်ပါလိမ့်မယ်သူ့ရဲ့ပညာရေးမှာဆိုရင်ကျွန်တော်တို့နော်ဒီလိုစေတဝန်ထမ်းအဖွဲ့အစည်းကဝိုင်းပြီးလုပ်ပါမယ်နော် NUG အနေနဲ့ကဆိုရင်တော်လိုင်းရေးကိုပဲအဓိကဦးစားပေးပြီးတော့ဒီစစ်ကောင်စီကိုပြုတ်ကြအောင်အထူးအာရုံစိုက်ပြီးတော့ပြည်သူလူထုဦးဆောင်ပေးပါလို့ကျွန်တော်ကနော်တောင်းဆိုရင်းနဲ့ဒီကုန်းချုပ်ပါနော်ကျေးဇူးတင်ပါတယ်
So today's lesson is we are talking about the emergency system. So the emergency system include the two systems, interruptible power supply and also the fire protection system. So uninterruptible power supply is powered by the battery. They are utilized as a standby alternator generator system. So emergency system, fire alarm system is emergency lighting. So emergency protection, fire blood protection, and emergency lighting and interruptible power supply system. They are the components of the emergency system. So the uninterruptible power supply is we call it a UPS. It called as a two system, offline UPS and an online UPS. Online UPS facility change over the switch to the base power to the UPS power when the supply is off. And also the online is the emergency supply is connected when the main power is off. The only essential loads are supplied. This is for the difference between offline and the online UPS system. Now here we got that this is a diagram of the offline UPS system. The main power supply include the body regulator, filter, and connected to the load, and also the battery charger, battery, and the inverter. So this way is a transfer from the this side to this side. Then when the main power is off, the switch go to the inverter battery side, and the load is continue to supply. When the main power is on, the battery is being charged. So that the main to the battery charger over time, or the battery to the main changeover time is typically 3 to 8 milliseconds. Within 3 to 8 milliseconds, the power will be transferred. The changeover is done by the transistor switch, transfer switch, when the power failure is sensed. So when the main power is failed, then is the sensor switch sense the main power, and then it transfers to the battery charger size, the battery size. So that by this way, emergency power is being supplied. Here is a diagram of the online UPS system. So the main system rectifier, and then we charge the battery, and then after battery power take out, go to the inverter and the supply will load. And here we also got a static bypass switch. When the main power is on, so this static bypass switch bypass the battery. But when main power is off, the bypass switch will switch off, and the battery will supply the load. So this is for the normal system and the emergency system. So the main power failed. When the main power failed, so this is for the battery is supplying the inverter and connected to the load. So this type of UPS system remain on the battery whether main AC is present or not. When the main AC is present, it provides power to the rectifier which charge the battery, simultaneously provide the DC supply to inverter that provides the main frequency and the body supply to the load. When the main power fails, the battery supply the load through the inverter. The system may be equivalent with the switching of non-essential load when the main power fails. So this is for the connection. Here will be the operation principle of online UPS. So this is the online UPS system. So here you see the main, rectifier, inverter, battery, band, static bypass switch, and connected to load. So this includes the transfer switch. Transfer switch selection mode is whether online or offline is embedded. The when to set the offline monitoring system or main power is also activated. The simplified block diagram of the system is shown in the figure. In this type of UPS, the system always remains on the battery, whether main AC present or not. When the main AC present, it provides the power to rectifier, which charge the battery and simultaneously provide the DC supply. So here is a connection of the electrochemical cell. Electrochemical cells are connection. This can be recharged to the cell. So this is for the anode and this is the cathode. So here is a solder bridge and a load. So when the solution containing the electrolyte ions, so the electrolyte ions are create the ions particle, so positive and negative charge. So this is copper sulfate solution. The anode electrode is the we provide the Cu2 plus, and also the salt bridge includes Ag, and also this is the Ag cathode electrode. So this is for the cathode anodes are called the positive and negative charge, and buying the electricity with supply. So this is what the power balance electro balance diagram of the copper sulfate, and also the electrode of the cell. So here you got this there will be the electrolysis. The dust of the dust given for the hydrogens bubbles are building up on the cathode, or the cell is done the electrolysis. So in this case you got this carbon zinc or lithium or the alkaline or mercury. So the lithium is a longest cell life. So they have the longest cell life. So in this case the open circuit voltage of lithium magnetic cell is a 3.8 volt. Open circuit terminal voltage of lead acid cell is a 2.105 volt. So the capacity is it can supply the 760 to 75 watt-hour kilogram. Operating temperature is a minus 40 to the plus 60 degrees centigrade. So this is the battery charging and discharging diagram. When the battery charge, there will be this is the constant voltage. So there will be the cells voltage and also the charging die. We can draw this the charging and discharge die. So this is charging graph and here is discharge graph. Battery capacity measured by the ampere hour AH. So we have to calculate the continuous current that a battery with the 300 ampere hour rating can deliver on the 10-hour discharge. So this is the current can be calculated by ampere hour divided by time hour. So 300 divided by 10, you got the 30 ampere. So this is the charge volt per cell 3.8. So capacity is the cutoff voltage and the charging die and the capacity with the full saturation. So this is the charge volt per cell and capacity the cutoff voltage and charging die and the capacity the full saturation. So the charging volt per cell and the relation diagram. Here is the battery equation. Battery equation is E is the electromotive force, E equal to V plus IR. So E is the electromotive force of the battery, I is the internal resistance of the battery, I is the current, I is the load, capital I is the load resistance, V is the terminal voltage of the battery. So we can write down that E is the V plus IR. So in this case, V equal to I into capital R. So the E equal to I capital R plus I small r. So the E equal to I capital R plus small r. So the I equal to E divided by capital R plus small r. The next one is a force alkaline mechanism. Cells are each with the open circuit voltage 1.5 volt. They are connected in parallel to supply the 8 ohm load. Supply the 3 ohm load, ignoring the internal resistance. We need to calculate open circuit voltage of the battery and load current and current supplied by the E cell. So this is the connection of the diagram. So each provided 1.5 volt and internal resistance is 0 and load resistance 3 ohm. So the series and parallel combination. So this is for the series combination. Is we can connect it. So in this case, this is for the diagram of this diagram. So in this case, series combination is all the voltages can be added together, all the internal resistance can be added. Parallel combination is all the internal resistance, reverse of the internal resistance addition, and total current equal to the I1 plus I2 plus I3. So they are the common voltage E. So for these reasons, this problem we calculated. So in this case, supply voltage is V. V is a 1.5 volt and divided by the load resistance 3. So you got a 0.5 ampere. So the average is supplying the current I1 plus I2 plus I3 plus I4 all combination 0.5 ampere. But all the I1, I2, I3, I4s are equal because they got the same voltage and the same internal resistance. For these reasons, 4 multiplied by I battery is equal to the 0.5, so the I equal to 0.115 ampere. In this case, also the in the above problem, is a battery internal resistance 0.040 and is calculate the current supplied by the E battery. So the E equal to 1.5 volt, 1 by R is 1.04 plus 1.04 plus 1.04 plus 1.04. So 1 by R is 4.04. You got the RD equal to the 0.01 ohm volt. So this is the way we calculate it. So in this case, the supply voltage is internal resistance 0.01 and then external current is resistance 3 ohm. So the E equal to I plus small r plus capital R. So the 1.5 equal to I into 3 plus 0.01. Then we calculate I equal to 0.498. So this is what total current. But each battery supply is divided by 4. You got the 0.124 ampere. So this is for the battery in the arrangement of battery in emergency system. So there are central system. Central system is a central battery bank. Is supplied to the main inverter and then we connected to the chain over switch. So connected to also the main power line, and also here you can connect it to the load. So this is a central system. Coordinated system is every system called the individual battery. So central system and coordinated systems are diagram. So in this case, there are two advantages. Cite the two advantages and the two disadvantages of the central battery system over the self-coordinated system. To provide the electrical power to the ingress and lighting during the time of main power failure. So in this case, advantage is one centralized battery provide for the required main maintenance time by the concentrating the battery source in the one space. So that in this case, a centralized system is easier to do the maintenance. In some installations, central system can be less expensive to the install. But this advantage is that all the cabling between the battery and the luminous must be the fire rated. There must be the MIMS or PVC in the C-U and radar battery as well. Failure of the battery means a total failure of the whole system. And the next one is the battery charging. These are three precautions which must be observed when the charging is charging in the standby battery. So the safety plug fitted to the cell must be firmly tied in the place at all times during the charging. Electrolyte level must be maintained and the electrolyte temperature should not be allowed to reach 45 degrees centigrade. When the boost or the supplementary change has been completed, when the boost or supplementary charge has been completed, the battery must be returned to the flow condition to prevent the damaging of the cells. So this is the changeover system. In this case, this is for the emergency system. So this is a standby portable alternator system. They can be the diesel driving, petrol driving, and gas driving. So this is the standby portable alternator, cylinder motor, engine, and small alternator is supplying the load, and also battery charger supplying the battery and supplying the excitation body. So in this case, we need to consider the amount of the load on the system, cost and the availability of the cell, amount of the load on the system, cost and availability of the fuel, and the maintenance cost. Those need to be concerned about. And the internal combustion engine has the power efficiency, but they're cheaper to buy. These engines are utilized as a main prime mover. They are the more expensive, higher fuel cost, less tolerance to the dirty fuel, and a higher maintenance cost, and a lower running cost per hour, and a longer and a more reliable life. So this is what the feature of the diesel engine. In the meantime, remote area power supplies we utilize the PV module or wind turbine or mini hydro. So this is the protection method. Is we have to protect these island protection because of the main power supply. In this case, we also need to off the grid connected PV module because they need to send the sensor, and then we have to off the inverter module. So the activate the circuit breaker to trade off. This is the way we provide this in the island protection. Why is active in the island protection, passive protection? Active in the island protection isolate the generation source from the distribution system in the event of the distribution system supply failure. Passive protection, in addition to the above and the island protection, the customer generation facilities must have the following minimum protection in inverter. They must have the overall under-voltage frequency protection, overall under-voltage sensor, and overall overcurrent and short circuit protection. Those are the requirements. So this is the diagram of the three-phase generator, load, and the changeover switch, and the supply connection. And this is for the main neutral link, and the alt link, and the load, and the generator, and the supply changeover. Emergency system and the normal systems are connection diagram. So in this case, schematic diagram of the emergency system. Here is a schematic diagram of the emergency system. So this is for customer generation. So this is inverter connected to the main switch and also normal distribution supply and the consumer load. So this is we use a connection of the customer generation source, and also that this is for the integration, interconnection, protection, inverter, and metering equipment they are provided. The next one is that we're talking about the fire protection and the residential smoke alarm system. So that to alarm the occupant of the building in the event of the fire breakout. So that when the fire breaking out, the smoke detector detect the smoke and the sound alarm. In the meantime, we also provide a sprinkler system. They produce in contain the smoke and heat detection, and then also automatic water spraying are functionally provided. So electricity supply to the smoke detector system, they detect the electrical supply to smoke detector, which cannot be interrupted by the main switch. So this is the this is sub main, this is main switch, this is sub main, but here is a direct connected to the smoke detector system. So this is just a operation of smoke detector system. Normally it's electrical power, so this is a smoke. When the smoke happens, it can be the ion. Positive and negative ions are particle happen. So the positive electrode, they go to a negative electrode, then the electrical current flow, the currents are sound the alarm. So the ionizing chamber contain a minute amount of the radioactive material, America. Under the normal condition, the airs are connected in the ionizing chamber, ionized, allowing the small current to flow from the battery through the chamber. When the smoke enters the chamber, it disrupts the current flow and activates the alarm. It's more responsive to the flaming fire. And then it says smoke alarms are considered to be safety device. The smoke alarms are not considered to be safety device for the purpose of the AS3000 standards. In this case, the type of the smoke detector is a carbon particle detector and a light detector system. Then we have to install the smoke alarm system. We have to avoid to install the smoke alarm at the dead air zone. This is for the this is dead end about from the 300 millimeter. This is the dead zone. We can install the smoke alarm system. Also, that we cannot install the air fluid coming from the kitchen. We can install the smoke alarm here because of the smoke alarm we sense the smoke from the kitchen. No, and also that it cannot be installed in the bathroom. There's a location of the smoke alarm where it need to be installed. We need to install a smoke alarm in bedroom as well as an alleyway. This is the smoke alarm system, electrical wiring system, active wire, neutral wire, and the interconnection. The location of smoke detector should be there close to the bedroom, and also top of the stair outside the bedroom. The ionizing smoke detector need to be installed. In the kitchen, we have to install the thermal smoke detector system. So limitation is avoid to install the smoke alarm in kitchen unless a thermal smoke detector is used, not in the bedroom, not in garage, and not in the very humid area. They must be the 3 meter from the bedroom and the 6.5 meter from the gas heater. So in this case, we have to utilize a cable selection. So the AS3000 2016, table 5x1, 5x2, 8x1, 8x2, those are the tables have to utilize. Okay, this problem, if factory installation has a 3-phase 400 volt supply, who has a multiple other than neutral connection, the maximum demand current of the installation is calculated at the 180 ampere phase. The greater portion of the maximum demand current is a balance over the 3 phase. The active conductors are the 3 single core non-armors of V90 insulated and a sheeted circular cable with the copper conductors. Installation of cable placed then in the rigid thermoplastic conduit varying the ground at the depth of the 500 millimeter at the ambient soil temperature 25 degrees centigrade. So this is what the problem is given. So this is the connection. So we have to connect the connection is the carrier program the circuit breaker. We have to determine the conductor side and side of the neutral wire. Cable length is 100 meter. In this case, they are table 3x1, 3x2. This is for the air 3008, table 3x1, 3x2 for the air, 3x3 and 3x4 for the underground. So in this case, thermoplastic conduit is in the thermoplastic conduit. This is underground enclosure. So we have to refer the table 3x4. 3 single core cable. In this case, we have to refer the item 2 and the semis enclosure is 22. So here we can see about the air 3008. Air 3008 here, and then we open the table 3.4 because of the underground enclosure. We look at the table 3x4 for underground enclosure. Okay, so this is underground enclosure, and then we can see about the item 2, 3 single core. This is single core 8, this is the item 2. 3 single core cable. In this case, we have to refer the table 7, 8 or 9. So the table 7 for V75, table 8 for the V90, and table 9 for V110. And also the derating is we have to utilize the same enclosure is use a derating table is a table 22. Those have to be utilized. So that this program is further referred to the another table because of the 3 single cores are cable. So V90 is a referred table 8. So this will be the V90. So there will be the table 7, 8, 9. In this case, V90 means that we have to refer the table 8. So table 8, column 24 to 26. Yeah, table 8, column 24 to 26 need to be referred. So we have to, and also the table 22. So table 8, we look at the table 8. Say 7, 8. Column 22 to 24. So this is table 8. Table 8, column 24 to 26. You refer the column, here is a 24. 24 to 26. In this case, we use as a solid conductor. Solid conductor, we have to use a columns are 24. Okay, column 24 we got. And also the this one, we also have to find the table 22. Table 24 is a derating factor. The derating factor, we have to refer the table 22. So in this case, the current is a maximum demand current is already given the 180 ampere. We have to find out the derating factor first. And based on the derating factor, we look at the tables are 8. So the derating factor, we need to find from the table 22. So that then we find out the table 22. So this is the table 22. Table 22, the how many circuit? There will be the 2 circuit. Because active and neutral, there are 2 circuit. So because of the 2 circuit, item is here will be the number of derating circuit, 2 circuit. So 2 circuit. Also the where the item is to select. they are not as it does not say about the separation. We assume that the touching. So this is touching is a which should be there. This is the touching. So that will be 0.9. Single layer touching. Single layer touching. So that will be 0.9. Single layer space on space was this is 0.9. So you utilize it 0.9. So we have got the 200 ampere we got. So the 180 divided by 0.9 we get this 200 ampere. Then based on this 200 ampere we utilize the table 8. So that this table 8 we look at. We look at the table 8. So this is the table 8. So column. So this table 8 from here we can see that column 24 to 25. So 200 MPI here 203. So that then we got there's a 70 millimeter square. So this area is we calculate is a 70 millimeter square. And then we have to find out the VC. VC is we have to find out there's a table 41. From the table 41's VC value is a 90 in 70 millimeter square 90 centigrade. Table 41 VC the 0.623. So this is the table 41. Because of the single core cable. So this is we refer the table 41 to calculate the VC value. So body draw calculation we utilize the table 41. Three-phase body drop because the three-phase body drop table 41. So this is 90 degrees centigrade, 70 millimeter square. So you here you got the 0.623. This is the VC value. So this VC value we substitute here, and length is 100 meter. Current is 200 divided by 1000. You got the 12.4 volt. So the 12.4 volt is 5% of the three-phase voltage at 415 volt. So in this case, less than the 5%. So this is the acceptable. And then we also talking about the electrical engineer trade practice. This is for the degree side, and also we also talk about the electrical engineer trade practice. Okay, trade practice trade 2 is we talking about the heating control. So the heating is to be control for the preventing the electrical wiring due to the over temperature. So that in this case, we have to utilize the Austrian standard. Heat is energy and can cause a damage by the starting the fire or the possible damage in the properties or damage to the people and the livestock. So the section 4x2 class 4x2.5 is provided to protection against the thermal effect. So table 4x1 also AS and there's 60335 household and the similar electrical appliance safety. They are the required Austrian standard for the heating. So the luminaire need to be separated from the source of the house to protect the heating and the electrical fire. The 4x5x2x3, this is the clause is mentioned about the install a luminaire in the suitable separation from the thermal insulating materials, combustible bearing element, and the loose combustible materials enclosure. It provides the required barrier around the luminaires or the provide the default clearance. This on the paper 4x7. So manufacture certification, suitable separation, enclosure and barriers are important aspects. So the electrical heating is that each of the conversion from the electrical energy to heat energy. The each of these are utilization of electrical energy or conversion process. The large amount of the heat and temperature that can be operated, the control of the process with this minimize appearance, gains are generated. Also that we have to utilize the control equipment. There will be the on-off control or the nichrome control based on temperature. Also the manual control system, we utilize the on-off switch and also portable heating apply, and the complex radiators we utilize with the manual control system. So this is for this control circuit for the heating the system, resistor, and the high and low the wire connection. When the high and the lows of the wires will be connected like this. Here is a force switch connection in the room. So control switch position. Here is the connection of the heat control system. High and low connection, the wire heating coil will be connected. Also, we also utilize the thermostatic control. It sends the temperature, time, and the steam pressure. So this is the connection of thermostatic. So the operating rod is for the support stand and the bimetallic strip. Temperature change. Heatless operation rod is a twisting, and it can provide the opening or closing, and then set the contact for the heating wire. We also utilize a semi-step control. The heater includes the bimetal strip to bend and the closing and opening contact with the snap action, and then load and the heater energize can happen. So here with the connection of snap action and the temperature controls switch diagram and their connection diagram. The semi-step consists of the heater that causes a bimetal strip to bend, thus a closing or opening contact with the snap action happen. Switching in close position both load and the heaters are energized. The current heater wants a bimetal strip which bend and open the switch contact. The three-phase water control system also applied. Three-phase automatic installation, three-phase automatic instantaneous style water heater is a not temperature control. The heater element is switched on off by the hydraulic diaphragm switch whenever the hot water tank is operated. Heat input to heater is constant. The temperature is only controlled by the variance of water flow. No thermostat is fitted. So modern heater has a high load switch fitted to allow the seasonal difference in the ambient water temperature. And also we are also providing electronic control. This is the phase control and voltage switching. We provide electronic control SER. So this is electronic switch. Electronic switch SER is connected on the electronic switch. No moving parts, no earth, and no affected by the dirty contacts. Electronically switch on off for the heating. So phase control is also provided. Phase and the fire. So phase and the fire control turn on the percentage of the each power line half circuit. This is the control of the phase control system. So this is the what is the main difference minimum distance from the front of the 100 watt incandescent spotlight. So in this case should be the 0.6 meter. We have to follow the AS3000 tables are 4x2. What is the minimum clearance required above the halogen light in the ceiling? So that this is the 100 millimeter. We have to refer the figures are 4x9 or AS3000. Take the maximum temperature of the plastic case of the electric power control. Power 2 is a 35 degrees centigrade. You have to refer the AS3000, they were 4x1. And list the two requirements of the luminance put it on the ceiling panel in the suspended ceiling. So in this case, we refer the AS4x5x2x4. Luminance dust are put by the ceiling panel shall not present in a mechanical loading. That AC the capacity of ceiling panel and operate at the temperature that's work cost. So what is the maximum kilowatt rating of the appliance from the 10 ampere socket outlet? So in this case, power has to calculate the voltage is 230 volt, 10 ampere, so you multiply, so the 2300 watt or 2.3 kilowatt. What is the danger of the breaking out of the thermal cutoff or the revolving is the pressure relief bar on the water heater. In this case, the over temperature, pressure, explosion, and the fire risk can happen. The appliance has a tools are 1.5 kilowatts element control. These the three heats are switching, calculate the state power in the load for the E-switch position. So in the connection is a series connection. The current is a half to the 0.75 kilowatt. Only one is applied, so 1.5 kilowatt. So that both are parallel, so they will be 3 kilowatt. State the maximum difference, main difference between the thermostat and the thermostat. Thermostat contains a circuit that the heating element to hold a specific temperature up to 320 degrees centigrade, and only enough heat is fed to the plate to maintain the set temperature. A thermostat control of the energies regulator adjusts the heat from the 0 to maximum on the scale to 0 to 10. What type of control for the water temperature may be used for the instantaneous water heater or the storage water heater? In this case, instantaneous water heater system, we use a fully electric and closed control loop, electronic closed loop control, and the electronic open loop control are utilized. Storage water heater, we use an electric resistant element to heat the water in the storage tank using the two electric resistant elements, which are located at the bottom and the top of the storage tank. Each element is controlled by independent thermostat. Lower element is utilized for the recovery and standby. Upper element provided the heating duration, the three-phase duration, the period of the large water heater use. A silicon control rectifier SEI, also known as a digestor. These are three methods in which the SEI can deliver the electric power to heater. In this case, we utilize phase control, phase and fire control, zero voltage switch, or the on-off control. So here we also read the tutorial. What is the purpose of the anode fitted to the main pressure glass line steel jacket hot water system? This is reduce the corrosion of the tank. How is the temperature of the instantaneous water heater controlled by the flow rate? What is the minimum AS3000 acceptable value of the insulation resistance for a sheeted heating element is a 0.01 megaohm. What is the collector mounted below the storage vessel in the solar hot water system? It is a maximize the water circulation using the thermosiphon principle. Why would the owner of the domestic resident opt for the alternative supply rather than connected to suitable wires electrical grid? So this is the cause of the grid connection. What is the principal operation of the UPS system? AC input and the battery supply connected in a parallel via a rectifier and an inverter. What is the main advantage of the hydroelectricity, which compared to the wind and solar installation is a 24/7 operation? Why does the number of the negative plates always exceed the number of positive plates in the lead acid battery? So this is to optimize the use of the positive plate. What is the difference between primary and secondary cell? Primary cell cannot be recharged. What is the main difference of the lead acid charge compared to other type of battery? This is the key. So this is for the tutorials problem also given. So the instantaneous hot water system has the 16 ohm heating element connected to star to 3,400 volt supply. So we have to find out the current draw by the supply. In this case, supply line voltage is 230 volt. So the phase voltage divided by the phase voltage 230 volt by 16 ohm. So the divided by the 14.375 ampere. And the 3-phase power √3 VAIL. So the √3 now VA is 400, IA is 14.75, and power factor 1. Then you got the power. And similarly, this problem is a data connection. In this case, IA is a √3 times IBH, VA VBH. So the IA is equal to VA by VBH is 16. So the 400 by 16 equal to 25 ampere. IA is a √3, IBH is the 40. √3 multiply 25 to 43.3. Then power is a √3 VA, IA power factor. So the √3 VA 400, IS are 43.3, power factor 1 equal to 30 kilowatt. And the emergency battery bank is to be set up to deliver a 24 volt 6 ampere for the 1 hour. The nickel cadmium cell are required at the 2 ampere hour and 1 hour rate. We have to find out the determine the cell require how the cell would be the configure. So in this case, power required 24 multiplied by 6, you got the 144 amp. So each academia cell is at 1 by 2 volt and the current 2 ampere, so that the power is 1 by 2 multiplied by 2. So 144 by 1 by 2 multiplied by 2, you got a 60 cell. So in this case, how the number of cells you charge is a required voltage. Divided voltage by cell. Required voltage 24, voltage by cell 1 by 2, so that 20. So that in this case, we have to see the 20 in series and with the 3 row. So the silicon control rectifier also we also the guys like this is for this problem we calculated. And we also see the 3-1 electrical workshop practice. So that this is we are talking about the mechanical drawing and the interpretation and sketching. So the purpose of the drawing is we have to do the communications between the people involved in the project. We can do the discussion, development of idea and the theories, and also the decision. Also the we call the record keeping for the future development. In this case, we have to utilize the AS1100 92 addition. This is for technical drawing and general principle. AS1101 graphic symbol for the engineer generals engineering. AS and AS1102 graphical symbol for the electrotechnology. Here is a type of the line. This is thick line. This is thin line. This is the view A. This is view B. So view A you can see this one. View B you can see this one. Here is a dotted line of the thin line. So thin line is a hidden line. This is also the end plate. We can also draw like this. So the brake line this is brake line. Here A is a brake line, bottom B brake line, C is the thin brake line. Brake line is we can draw by this way. We cut the section, so this is a section diagram. So from the 8H view, we cut the section, so this is the cut pieces. So this diagram you can see what this diagram is. We can see the type of the diagram. We can see there's a different C's. You see this block. From the A view, B view, C view, you can see the diagram like this. So this is the diagram of the electric switch outlet. So this is for the rear diagram, rear connection diagram. So this is a rear connections switch board, and we can draw the block diagram like this. So this is the rear connection of the electrical switch. So the orthographic projection, this is the orthographic isometric orthographic projection. So that this is the isometric view, 3-dimension view. You see the view A, view B, view C, you can see diagram like this. Also this diagram, you can see the 8H view. We cut in the 8H, you can see the diagram like this. So that this one is you have to do the practice. So this diagram you can see the 3-dimension. So that you can see the view A, B, C, you can see like this. So A side here, A, from the B, you can see B, and C side like this. Also this diagram, also you can see the B, so this is B, from the A, you can see like this, and C, you can see like this. So this one also the 3-dimension, so you can see that from the B, you can see like this, from the A, you see like this, the C, you can see like this. So this is the we have view of the isometric view of the different view. So this one you can see the ABC. From the A side you can see like this. This is B, you can see like this. From the C you can see like this. So this is the 3-dimension. From the A view you can see like this. From the B you can see like this. From the C you can see like this. So that we have to do that exercise on this diagram. So this is for the drawing A4 sheet dimension A3, A2, A0 to the A4, the dimension you can draw like this. Also the we also use as our information on drawing, so we have to include the company name, owner of drawing, part name, items or the part number and drawing number need to be utilized. The sheet number, sheet size, and scale of the drawing, projection size one, finish general survey, finish required on the part, and general tolerance, and the draft person initiate, draft person who check the drawing, they are drawn and they are issued, those need to be included in the drawing. And then we also continue the diploma. YouTube video lesson. So last week we already finished E026 engineering mathematics. Now we are talking about the E029 electric motor drive. So in this case we have to refer the highlight computer.com/video lesson.pdf. So page 51 to 57 you need to look at. This is for the today lesson. So we see the video.
This is the lesson for the E2019 trends. So this topic is 1 plus 2 electric motors are drive part 1. So when the motors are running, sometimes the voltage can be the imbalance. So when the voltage imbalance happens, it can affect the currents at the normal operating voltage are very imbalanced. Reduce full of speed and noise and the vibration happen. So this is the effect of the voltage imbalance. So the positive voltage imbalance can be calculated by the formula. The formula is the maximum deviation from the average voltage divided by average voltage multiplied with 100. So that when the different voltage are given, so that we have to find the average voltage and then you also have to find the maximum deviation. So maximum deviation voltage divided by average voltage in multiplied 100, then you can calculate the positive voltage imbalance. So based on this formula, we calculated this problem. So 3 voltages phase to neutral are measured to be 220, 215 and then 210 volt. On the non-luminance are 415 volt, 50 hertz supply. Determine the positive voltage impedance. So there are 3 voltage, 220, 215, 210. So you have to find the average voltage. 220 plus 215 plus 210 divided by 3, so 215 volt. So this is the 215 volt is the average voltage. So maximum deviation is you see the 3 voltage here, maximum value 220. So the maximum deviation from the average value is 220 minus 215, so 5 volt. Then we substitute this formula here. Maximum deviation from the average voltage divided by average voltage is 100. So the 5 divided by 215 is 100, so 253%. So motor is running. So the motor can be calculated we can calculate the synchronous speed. Synchronous speed and that is equal to 120 F divided by P. So F is the frequency, P is the number of volts. So motor torque can be the starting torque
loud rotor torque, breakaway torque, and the pull out maximum torque. So starting torque means that when the motor starting, motor needs to overcome the motor inertia, so that this is the starting torque is has to be great. And this is loud rotor torque is that we have to lock the motor rotor, and we can measure the torque, so that the torque requires lock the rotor. Pull out torque means the maximum torque. So when the motor is running, the maximum load can be supplied by the motor depending on the maximum torque. So the torque is the proportional to the body square. The current flow from the supply is also proportional to the body. So the motor current proportional to the body, motor torque proportional to the body square. So the motor starting currents are typically 450% to 600%. So therefore the starting current is higher. So we have to utilize the reduced voltage starting method to reduce the starting current. So the driving torque means that the driving torque must be capable of supplying the maximum torque, likely to be encountered at any time during the speed cycle. When the motor is running, sometimes the motor torque, load torque can be higher. In this case, motor must have the appropriate driving torque to overcome the load. Otherwise, motor will stop it. So that sometimes motors are running, sometimes motors stopping. So the motor run, stop, happening frequently. So this is what we call the duty cycle. So depending on the kind of the duty cycle and the kind of the type, we can classify. Motor duty type can be classified from S1 to S8. So then, for example, some motors are running continuously, some motors are running intermittently. So those things are determined by the duty types. And motor classes, some of the motors require the high starting torque, some require the low starting torque. So which motor require the high starting torque, which one will require the low starting torque, can be determined by the motor classification. So the motor classification can be the N, NR, NS, NY, H, HR, HS, and the H1. So what kind of the motor classification? So all the motors are classification, they follow the appropriate AS standard. AS 1359.20, 21, 22, those are Austrian standard. They can determine the motor classification. So the motor classification can be the 1 to 6. So the type of the enclosure can be open or splash road. So that they are the typical types are the IB8, IB22, IB11, IB24, IB35, IB22, IB43, IB44, and the Flame Pro. So the Flame Pro types has to follow the AS at 2080. So all the motors for the equivalent inertia can be calculated. Those moment of inertia multiply, those speed divided by motor speed square. So that when the motor speed is changing, so that the time required to change the motor speed can be calculated. Delta D is going to be JD by 9.55 multiplied with delta M by DAV. So JD means the equivalent inertia, delta N is the change of the speed, DAV means the average torque. Average torque can be calculated D is equal to P by 60 divided by 2 by N. D is the motor power in watt, N is the speed, D is the torque. So that when the motor speed changing, so the time required to change can be calculated by this formula. Delta D is going to be JD by 9.55 multiplied with delta N divided by DAV. JD is motor inertia, delta N means that motor speed, average speed, change of the speed, DAV is the average torque. Torque equal to P60 divided by 2 by N. D is the power watt, N is the speed.
Lesson 2.
So based on the electric motor drive power theory, you're going to study the topic 1, electric motor selection and application, study the slide 1 to 9, and do the exercise question 1 to question 9. Topic 2, duty type of the motor, study the slide 1 to 11, do the exercises question 9 to question 17. Okay, another topic will be electric motor drive part 2. So the motors are, when the motors you connect this electric supply to the three-phase induction motor, motors are withdraw the higher current at the starting time. So the starting current needs to be limited. So typical formula is IST is equal to 53 plus 3.3 K. So this is the 53 and 3.3 are constant, K is a kilowatt output. And motors are rated more than 6 horsepower. In this case, starting current must follow this formula. IST is HP multiplied 2.5 plus 33A. So So those formulas are the not universal formula. This is the typical formula. Typical formula supplied by the relevant motors are manufacturer or relevant steel councils, relevant supply authority. So depending on the which kind of the motor you are utilizing, so you have to follow the appropriate static current formula recommended by the motor manufacturer. Okay, so based on those formula, we calculate this program. Determine the participant static current. Motor 1 is 15 kilowatt, 3 and 250 volt, and motor 2 is 15 kilowatt. Okay, so motor 1 we can calculate. IS is 50 plus 3 by 3 is 8. So they use 50 plus 3 by 3 is 50, so we call it 1.5 ampere. Motor 2 is 15 kilowatt. 15 kilowatt divided by 746, you call it horsepower. So horsepower multiplied 2.5 plus 33, so we substitute this formula, so the motor 2 is 3 by 3 ampere. So this is for the two motor situation, we can calculate the static current. In the meantime, we also utilize the motor starter. Motor starters are utilized to reduce the static current. So they can be the automated starter, this is the sequence control, and non-automated hand operation type starter. So those starters can be operated by either manual operation or electromagnetic or the pneumatic operation. So but when the motor is running, so sometimes you need to switch off the motor. So in this case, this is for the supply protection. So we can utilize the air brake circuit breaker or YMR circuit breaker or vacant circuit breaker. So when we are using the motor starter, the reason is to reduce the static current. So static current can be reduced by using the starter starter or the auto transformer starter. In this case, the current at the starter starter is equal to I divided by 3. So the starting current of the starter is equal to direct online starting current divided by 3. The starter is equal to T divided by 3. This means the starting current of the starting torque of the starter is equal to starting torque of the direct online starter divided by 3. I auto is equal to percentage E by 100 into I DOL. This means the starting current of auto transformer starter is equal to percentage voltage divided by 100 and starting current of direct online starter. T auto is equal to percentage E by 100 square and T DOL. So starting torque of the auto transformer starter is equal to percentage E percentage voltage by 100 square and starting torque of the direct online starter. So this is the torque and the voltage equation for the star delta and the auto transformer. So we can also utilize the synchronous motor. Synchronous motor basic construction is DC free excitation plus three-phase supply. So the two supplies are supplying to the motor. So DC free is supplied by the feed DC generator, and three-phase supply is supplied by the three-phase supply system. So there are two typical construction, spherical and the serial flow machine. So those synchronous motors are utilized because it can change the variables of power factor. So the protected devices utilized are the current sensing device, temperature sensing device. So when the current in the motor is higher or the temperature higher, so this sensing device can switch off the motor